We're going to continue talking now about hybridization models. And so in our last video, we explained how the geometry of methane, we can explain that geometry using the sp3 hybridization model. And in those hybrids that we formed, there is one s orbital mixed with 3p orbitals. So we can say that 1 out of 4 total orbitals is S. So we're going to say this is 25% S character. And 3 out of the 4 orbitals is P. So it's 75% P character. And that will be important in regards to the size of the orbitals, because if you remember, the S orbitals, the symmetry is sphere, but in the case of the P, they are like that. So the more P character the orbital, the hybrid have, the longer the mixed orbitals will be. So say that they will have a lobe like that, and one is kind of chubby. Let's say when they mix, about the shape. Now, we're going to talk now about another type of hybridization. Let's say that I have this, ethylene. How can I explain that? So for that, notice that I have 2 carbons and that I have a double bond. So I need to make 1 sigma bond and 1 pi bond. Explain how to make that. So for that, we're going to go back to the diagram that we had before. Notice that if I need to make a double bond here, and I know that I have a sigma and a pi bond, and pi bonds are weaker, we're going to make that, we're going to understand how we can make those by proposing another hybridization model. So here's the 1s, and we said in the previous video that we have, here's a 2s, and we say that we promoted 1 electron from the 2s. Here I'm writing the 1s in the 1s, and we had promoted 1 that was here over to the p, to the 3p's, and now we have this is 2px, 2py, 2pz, the 3. But now we made methane out of that, mixing for this 4, as we have here, 1s in the 3p, we mix those, and we make those 4 hybrid orbitals. Now, to explain this geometry, now we're going to do a different mix. We're going to mix 1 s-type orbital with 2 p's, and because we're creating that mix out of 1, 2, 3 orbitals, so I have 3 atomic orbitals, and I'm going to make 3 hybrid orbitals, and those I am going to call sp2, and essentially 1s and 2 other p's. That's the name we're going to give it. And notice that I have 1 p unhybridized, 1 p unhybridized orbital. And now I'm going to do the picture of what it would look like in the case of ethane. So I'm going to erase that. Ethene, the alkene. So erasing that to do the geometry. Notice that I have 2 carbons here, and the 2 carbons are going to be, we're going to explain the geometry using this hybridization model, sp2. So I'm going to start drawing this, and so now each of the carbon will have 3. I'm going to just draw just 1, and drawing these 3 atomic orbitals to be as far away as possible. They're going to be in a trigonal planar, the 3 bonds. And so here, each of the carbon will have these 3. The sp orbitals are going to be oriented like so. They have another small lobe, but they also will have each of the carbon 1 p unhybridized orbital, and it would look like that. So these 3 are in a plane. triangular planar geometry, and the P unhybridized is perpendicular to that. So I'm going to put two of those together to make this molecule, ethene. So putting those together means that I am, let's make it a bit different. So I'm approaching, let's say this, and I'm going to have the other carbon bonded to this, and that will be a sigma bond that is formed by the overlap of one sp2 and another sp2 orbital coming from each carbon. Now, each of this carbon is going to have one of these, two more sp2 orbitals, and here I have two more sp2 orbitals. But I'm going to put those, now this is in this plane. Here, the three sp2 orbitals were in the plane perpendicular to the board, and the p unhybridized was here in this board. In this drawing now, the p orbitals are here, but I'm going to need to draw the p unhybridized perpendicular to that. So it's going to be, now, because these are in the plane, I'm going to draw now this in the plane perpendicular to that, and there is a pi bond made of the overlap, and notice that the overlapping pi bond is like that, like this. This is a pi bond, right? So, and in the case of the sigma bond, notice that the overlap is like, say that I have these two markers face to face, like that. In the pi bond, I have it like that. The overlap is lateral. In the sigma bond, it is like that. I'm going to put it like so. See? It's different. And now the other bonds, in the case of ethene, I'm going to use another color here. I need my 4 hydrogens. And hydrogens, what they have, the electron is in the 1s. So here I have a hydrogen, another hydrogen, another hydrogen. And this is what I have. This, I'm just going to describe the bonds. And here, this is a sigma bond made of the overlap of one sp2 and one s orbital. All of the bonds to hydrogens are going to be described the same way. And that explains the geometry of ethene. And this is, as you notice, all of the atoms are in the plane of the board, like that, and the pi bond is like that. Okay, so, but all the atoms lie in one plane, so that geometry is planar. That's all for now.